Let's go over a couple of practice problems for this week's discussion quiz. In question 1, we will differentiate, and here we have the function y is equal to the natural log of x plus 1 to the 5th times x to the power of 10. Now we have a rule for logarithms, it's 1 over this expression here, but you can also use properties of logarithms to break this apart before differentiating. I'm going to take that approach. This is equal to the natural log of x plus 1 to the 5th plus the natural log of x to the power of 10. The rule that we are using here is if you have the natural log or any logarithm of a product of two expressions, this is equal to the natural log of a plus the natural log of b. Next, if you're continuing to simplify the expression, this exponent of 5 and this of 10 can be brought down to the front of the logarithm. So that is, we have 5, the natural log of x plus 1, plus 10 times the natural log of x. So here the property that we're using in this step is if you have a logarithm of some expression to a power, you're allowed to bring the power down front. Now that we have this function simplified, not differentiated but simplified, we can take the derivative from here. Now for taking the derivative of a log function, this one's of x and this is of x plus 1. If you differentiate the natural log of, I'll call it u, it's just some expression that depends on x. The rule is 1 over u. But by the chain rule, you have to multiply by the derivative with respect to x of whatever is composed inside the function. So starting here, we're going to find dy dx. This is going to be equal to 5 times 1 over x plus 1. Now, because the derivative of x plus 1 is just 1, that would go here. For emphasis, I'll put multiply by 1. Now to this, we're going to add 10 times the derivative of the natural log of x, which is simply 1 over x. Since we do not have to simplify our answers, here it is, the derivative with respect to x. In part B, we're going to again differentiate. So here the function is f of x. We'll solve for f prime of x. I see that we have an inverse tangent and arcsine, which is really inverse sine. So for this reason, we have to use the following rules. When you take the derivative with respect to x of tangent inverse of some function, the rule is it is 1 over 1 plus u squared. But by the chain rule, you have to multiply by the derivative of whatever is composed inside the function, which is u, and I'll express this as u prime. There's also a rule for the derivative of sine inverse, which you can write as arcsine. So the rule for this one is, it's kind of similar. It's 1 over, but you have the square root of 1 minus u squared. Now again, because something in here might not just be x, it could depend on u, by the chain rule you have to multiply by the derivative of u, which I'll express like that. So referring to these two rules here, if you'd like to find f prime of x, for tangent inverse, it is 1 over 1 plus whatever is composed in the function squared, and that is 1 minus 5x. Now by the chain rule, you have to multiply by the derivative of whatever is just in here. 1 goes to 0, minus 5x goes to negative 5, and so I'll put minus 5. Next, we subtract off the derivative of whatever we get from arcsine of 4x minus 3. The rule is 1 over, so I'll start there. It is 1 over the square root of 1 minus. Now u is equal to 4x minus 3. It's whatever is composed with inside the function. And we have to square it, so I will square it. And then we have to multiply by the derivative of what is ever composed inside of the function. This minus 3 goes to 0, the 4x goes to 4, and so I'll put 4. This is unsimplified. You can leave it as such. I think I'm just going to note that this 5 and this 4 came from the chain rule. And with all that being said, this is the answer for this problem.